Thank you for your consideration for a grant from the Sloan Foundation. As you've no doubt read our proposal to use artificial neural networks to better model air pollution, I am Knall. I will be your guide to this presentation. Air pollution is a public health issue affecting everyone in varying degrees. This presentation will be an exploration as to why our team is well suited for the Foundation's money to invest in methods to push us closer to solving this public health issue. Before we explore what our proposed technology can do, it is important to look at what the current technology is able to accomplish. The current air pollution modeling technologies are reliant on multilinear regressions. Multilinear regressions are used for predicting trends assuming a linear relationship between variables. Data collection is often done in urban and city areas, with the frequency of collection being every 3 days, or whenever air pollution is quite high. The places without physical data collection points rely on this prediction to extrapolate their approximate air pollution levels. The data collected is useful for normal case scenarios, but has some hard times extrapolating for ones outside of the normal range. The current method of modeling has a couple of issues with it. Current models are great for predicting low to normal levels of air pollution, illustrated by the standard deviation curve. The current modeling techniques leads to accuracy being concentrated in the middle of pollution levels. However, the current methods are not well equipped with accurately modeling extreme or heavy case scenarios. The more accurate the models are, means a better understanding of the problem. Better understanding of the problem leads to better solutions created to counteract this situation. After outlining the issues with the current technology, let's look at the comparison for our proposed technologies. Current air pollution modeling is best for low to moderate levels of air pollution. Data collection is done quite infrequently, being collected regularly once every 3 days, and data collection is often done in very select urban and city areas. The proposed technology of using artificial neural networks in modeling air pollution is pushing the frontier of scientific research, something that the Foundation is very keen on. It is able to model all levels of air pollution and extrapolate data more accurately. Through the use of nodes and newer existing technologies, we can achieve real-time data collection. Collection will be more comprehensive due to mobile collection nodes on cars as well as stationary ones on public buildings. Now that I've stated what the new technology can provide for this problem, it is important to see how it affects people's lives today. Air pollution carries a litany of risks associated with. Some examples include accelerated aging of the lungs, lung capacity decrease, asthma, bronchitis, emphysema, and cancer. All these diseases are created or exacerbated by air pollution. Long-term exposure to even low levels of air pollution is similar to short-term exposure to high or moderate levels of air pollution. The data collection process will be done using stationary nodes on public buildings like schools, libraries, police stations, while mobile data collection nodes will be created by our engineering team to affix to researchers' cars, eventually distributing them for free to anyone in the public in the interest of public engagement and increasing the awareness of this issue. Eventually, we hope to achieve real-time data collection. This constant monitoring will provide more detailed data for the artificial neural network to process. Creating the framework for the artificial neural network would take roughly a year to complete. Training the artificial neural network will require months, if not years, of time and effort. Monitoring and feeding in accurate data is a daunting task. Much like learning anything new, it takes patience, hard work, and dedication to complete the task. Eventually, all of this training will pay off. So you may be wondering who exactly will be handling this daunting task. Our team of statisticians, biologists, environmental scientists, product engineers, computer engineers, and artificial intelligence programmers will be the ones to handle this process. We want to promote a diverse work environment because diverse backgrounds means having a more comprehensive and multi-perspective view of the problem. Another goal of the Foundation is to promote a greater workforce. Not only will we be taking experts from the field, but we will also be offering opportunities to undergraduates in the form of internship and lab assistants. This will allow more people to contribute to the research, and we hope that eventually cooperation throughout the scientific community will increase. Cooperation at this scale may be a tad optimistic, but it's something that Mr. Sloan would have argued for. So the consequence of the end would mean that we would have more accurate models, better data analysis, and more accurate pollution origins. Finally, it would push not only innovation in air pollution modeling technologies, but also cooperation between scientific fields. Thank you for your time. I hope you have a wonderful day.